Hey there, chemists. Welcome to another exciting lesson in our organic chemistry unit. Today we're going to be taking some time to talk about a new organic reaction called fermentation, as well as the naming and production of alcohols. So let's go ahead and dive right in. Something that I find to be particularly fascinating about fermentation is the number of products that it's used to create. So, for example, Greek yogurt is made with the process of fermentation. Maybe you've heard of kombucha, which was really big for a while. I guess it still is kind of big, and it's a tea, and that's also used. That also uses fermentation in order to create that tea. Even the process of bread making uses fermentation and production of everyday alcohols that people over the age of 21 consume, like wine or beer. So our question is, how does fermentation work and what is the process of fermentation? So let's go ahead and take a look. Now, taking a look at the reaction, I've actually provided us with an example of a fermentation reaction. And the reactant that's there, that cyclic looking organic molecule, might be familiar looking to you. And that's because this molecule is glucose. And you probably talked a lot about glucose in your living environment classes. And so glucose, or an example of a sugar, because fermentation is going to require sugar, okay, glucose is going to react in the presence of yeast. Okay, yeast is not necessarily a reactant, but yeast does need to be present in order for fermentation to occur. And as a result of that, we are going to produce an alcohol, okay, and we are going to produce carbon dioxide. Okay, so how do I know that this is an alcohol? And I guess maybe I've already answered the next question below on the sheet, which is to identify the class of molecule that the product belongs to, which is the alcohol groups. Okay, but how can I explain that classification? Well, in order to explain that classification, you're going to want to be able to use your reference table. Okay, again, reference table R is going to be a series of organic molecules here, and in our table R, we can see that alcohol is going to be our second group down that we're going to be talking about. So how do I know, just by looking at that molecule, that this is considered an alcohol group? Or an alcohol molecule? And so taking a look at the molecule itself, notice that the base of our molecule, okay, is going to be a hydrocarbon. So our base is a hydrocarbon. And what's new to our molecule that we're taking a look at here is going to be this OH group over here, okay, which is what we call functional group, and we'll define that in just a moment, okay, but it contains the OH group. Now, I've been using that term functional group for the past couple of days to talk about halocarbons, and I think it's time that we kind of define what a functional group is. So a functional group, okay, is going to be used to classify organic molecules, and it's a functional group because it helps us to distinguish, or rather it is what is responsible for the properties of the molecules, okay? And so the functional group of OH is going to be what gives it the properties of an alcohol. Now, taking a look again at your reference table, alcohols there's four main columns on table R that we need to look at. There's going to be the class of the compound, the functional group, the general formula, and then again, it provides you with an example and a name. So when we are looking to identify organic molecules, what we want to do is look for a specific functional group and then match our molecule to the general formula. So as I mentioned, our functional group here is this OH. We've already circled it. This is our functional group. And then notice that under our general formula, it also specifies that we want to see an R group. And again, remember R, as I mentioned in our previous lesson, is going to be any halocarbon, any hydrocarbon, okay? So our R group is that C2H5 followed by the OH group, our functional group. So the above example was an example with glucose of the fermentation reaction, but what's going to be our general formula for fermentation reactions? What are we looking for in order to identify a fermentation reaction? So a fermentation reaction is always going to be some form of sugar. Now again, in the above example, we used glucose, but there's other sugars like fructose or sucrose, and typically we know it's a sugar because it ends in OSE, okay? So it's going to be sugar and yeast, and it will always produce alcohol and carbon dioxide. And so if we're looking to identify a fermentation reaction, we do want to make sure that we are always producing not only the alcohol, but also the carbon dioxide group. So alcohols, again, functional groups of OH. So as you guys can see here from our 3 molecules, we have 3 examples of alcohols. Just to prove it to you that they're alcohols, let's show that functional group. I have an OH group in molecule 1. I have that OH group in molecule 2. And I have an OH group in molecule 3. But how do I name these alcohols? Now again, if you're ever stuck on how to name them, you can try to use the example that's been provided for you, 1-propanol, in the reference table to try to come up with that rule. But what I'm going to do is I'm actually going to provide you the names of these molecules. And what I want us to do is think about a step-by-step process we can use in order to name them. So our first molecule here is 1-butanol, okay? Our second molecule is 1-pentanol. And what I want you to do is kind of pause the video and see if you can figure out what is the name of our third alcohol there. So go ahead, take a moment and pause that video and unpause when you're ready. Welcome back. Hopefully you paused to give this a shot. Let's go ahead and name this third alcohol, which is going to be 3-pentanol. Did you get it correct? If so, congratulations. If not, that's great. Thanks for giving it a shot. Let's go ahead and talk about how we name these molecules. So let's take a look at number 1 to help us come up with our step-by-step process. Now, first and foremost, we're going to try to kind of follow along with the same way that we kind of did alkanes, alkenes, and alkynes. First thing that we want to do is we want to take a look at our parent chain. And so our parent chain for carbons, notice that we still have our prefix of bute. So step 1 is going to be to name the parent chain. Okay. And next thing that we want to do is end our parent chain or give our parent chain an ending. And because our parent chain has this anol at the end, where do we think that comes from? Why the ending anol? Okay, and it comes from this fact that it's an alcohol. So name the parent chain plus anol because it's an alcohol. And then the last component of this that we need to kind of talk about is the number. So again, number 2 for naming here, we want to locate the OH group and number the parent chain so it is at the lowest possible carbon number. Okay, fantastic. Well, guys, nice, short, easy lesson today. Tomorrow, we're going to practice a little bit more with naming alcohols and identifying fermentation reactions. Have a fantastic rest of your day, guys, and I will see you tomorrow.